My name's Errol Brandt, and today I'm delighted to be presenting to you my research project, which aims to understand the impact of accelerating employee productivity with artificial intelligence. The technology I've developed uses a technique called cached augmented generation, and my broad research objective is to demonstrate that this approach is better, cheaper, and faster than traditional generation techniques. For those of you I haven't met, I completed my doctorate in business administration at Sturt University, where my research focused on leadership behaviours in the Australian manufacturing sector. This academic foundation, combined with my 3 decades of experience working in multinational manufacturing companies, has helped me define a somewhat unusual approach to business analytics and artificial intelligence. My academic research specifically investigated organisational barriers to change, and this led to the conceptualisation of Kiraa, which is what I call the world's first virtual business analyst, because she completes many of the analytical tasks currently completed by humans in the workplace. 3 years ago, I left my corporate career to form a startup company which aimed to capitalise on this enormous potential of AI within this context. And this has subsequently led me to focus my efforts in creating a new world-leading approach to business analytics that directly uses the knowledge I obtained during my doctorate. The purpose of my presentation today is to share with you the early results from the 3 years of operation in our startup and invite you to collaborate with us as we reshape the way that businesses make decisions in this new era of artificial intelligence. Okay, so let's start with the problem that I'm trying to solve. Let's think back to the 1990s when computerization became mainstream. The first jobs that we saw disappear were the typists, because all of a sudden employees started to get desktop computers which could allow them to write emails and prepare presentations and conduct an analysis without the assistance of others. This technology unlocked a wave of productivity, and we quickly started to find new ways that we could produce more and more information more quickly. Now, if you roll the clock forward to today, employees are inundated with information. Email inboxes are filled with emails and reports and dashboards, and there's far more information produced than any person can fully analyse. Our ability to generate information exceeds our capacity to analyse information, and that's what's causing a stall in enterprise productivity. 50, or 100 years ago, information was really scarce. We didn't have the technology nor the infrastructure to generate and communicate information quickly. We relied on filing systems to locate important documents and also physical transportation of paper in order to communicate ideas between geographies. Today, it's never been easier to generate information, and we now have systems, dashboards, and processes and spreadsheets for just about everything. We're generating information so quickly now that we're having to build more and more data centers just to hold it. We think nothing these days of the apps that we use on our phone, which analyze and collect information in real time, nor the numerous forms of communication channels that we use to share that information with people. The problem we have today is not a lack of information, but too much of it. Too much information is probably more of a problem than a lack of information, because it means we need to select which ones that we want to use and which we want to discard. This abundance of information has led to a phenomenon which Herbert Simon calls bounded rationality. And that means that business leaders who make decisions are limited by their cognitive capacity, their available time, and the quality of information which they're receiving. So rather than perfectly optimize, people do something that Simon calls satisficing. We settle for good enough. It's a good enough choice because we can't examine everything. And the reason why they do that is if you don't satisfy us, if you don't make some very important choices around which information to consider, you become overwhelmed and you end up finding that decision making slows or stops altogether. Research on information overload shows that too much information impairs the ability for timely decision making, which hurts both the speed and the quality of the decisions being made. In other words, more information isn't always better. In fact, it often leads to a worse outcome because it overwhelms people. So the challenge that we need to deal with is find a way to make information usable. We have to filter the noise. We have to find ways to highlight what matters and present it to people in a very easy consume way. Solving this problem is key to enabling faster, more effective business decision making. So according to Herbert Simon, people can't process all available information, and we operate under cognitive limitations and time restrictions. So therefore we have to choose between satisficing, being good enough, or optimizing. So instead of making perfect decisions, we need to choose an option which meets basic criteria under the circumstances. Of course, gathering and collecting information has cost and also adds time. So we also need to be considering how we reduce the complexity of our information processing so that we can operate within human limits and use technology to do the things that it does best and allow humans to do the things that humans do best. So let's delve deeper into the concept of bounded rationality. The concept of bounded rationality was coined by Nobel laureate Herbert Simon, and it really recognized the fact that the decision maker has limited time and limited cognitive ability. Imagine trying to read every report or consider every possible outcome. It's simply impossible. So rather than consider the classical economic person idea, which is both rational and optimizes decisions perfectly, in the real world it doesn't work like that. People satisfice. We stop searching when we find an option that seems good enough. This isn't laziness. It isn't even necessarily a bad thing. It's just a rational response to complexity and deadlines. Simon also talked about the cost of information. Every extra data set, every extra piece of analysis adds time and effort. And of course, the longer that decisions take to be made, the less valuable or the less impactful they might become. So providing all the information isn't helpful at all. In fact, it overwhelms. What we should be focusing on is finding information in a form that's digestible and relevant to the person making the decision. And it's this theory which really sets the stage for the AI strategy that I've developed. These days it's known as cached augmented generation. And it's really a strategy which simplifies and pre-processes information in a way that allows better decisions to be made more quickly. This theory underpins the AI strategy that we've developed in our product using cached augmented generation technique. This is a strategy which simplifies and pre-processes information, and it aligns with the delivery and the limitations that real humans have in terms of making decisions. So let's take a step back and now talk about the role of AI in decision making. And there are a lot of very good reasons why you would want to use artificial intelligence to help accelerate business decision making. The first reason being the fact that natural language is so much easier for humans to use than some sort of technical code or formulas. And the good thing about large language models is they're built around language, which for a human is the most efficient interface that we can have. Of course, the other advantage of large language models is you can question them, you can discuss with them. So users can ask questions in plain English and the AI retrieves the answer and presents it back to the human in a very easy way. Now the problem though with this approach is that it can be slow and expensive, and even though we've got products such as ChatGPT which ostensibly are free today, they won't remain free forever. I think a lot of people forget that we're in the investment stage of this new technology, and a lot of people are investing early to recruit customers, and they're doing things which I guess on the longer term are not commercially sustainable. But they're doing that because they know that if they don't play in this space now, they may lose the advantage forever. So we're seeing a lot of what you might call irrational pricing when it comes to some of this technology. So we need to be mindful that the cost of AI that we're using today won't remain that way forever. The market will consolidate, prices will rise, and all of the investment that the big technology companies have made for free will be recouped in another way. If you're familiar with AI, you'd understand that generative AI offers a pathway out of this information overload nightmare. Our AI models are now extremely good at summarizing large volumes of information and identifying the key facts and insights. But there's a couple of major limitations that practitioners who work in this space and actually understand the problems have identified. And these issues are significantly limiting the ability for organizations to make the best use of artificial intelligence technology. So in a sense, what we're trying to do is retrofit AI into existing technology paradigms. And this is why you see Microsoft adding tools like Copilot onto their solutions, and with limited success, because essentially we haven't really fundamentally re-engineered the technology for AI. We've simply bolted it on and hoped that everything continues to work better than it did before. And it's this thinking which has led to the current approach for business analytics, which really involves users interacting with a large language model, which then converts their questions back into code, which accesses the information from source database systems. And this is kind of a good first step because it makes it easy for the humans to ask questions about the business information. But it does so with a whole series of processing steps which add both time and cost to the transaction. Now, of course, we can get around that problem by making faster and faster computers and with bigger and bigger memory. But there is a limit at which we can expect this technology to tap out. And this approach is fine because it makes it easier for humans to ask questions about their business information. But it does so by involving a whole series of processing steps which add both time and cost to every question. This approach is okay for trivial or low-value use cases, like the sort of things that people do with ChatGPT. But it's not suitable for high-value business use cases. For example, for financial analytics or legal or medical analytics, which has absolutely no margin of error. And the error I'm talking about here is hallucinations. And one of the downsides that we have with the current approach is that large language models are highly susceptible to hallucinations. And part of that is because of the way that we've bolted on AI onto our existing systems and ask it to go and retrieve and make assumptions about the underlying business data. And therefore, the existing processes, while they may support in some way, they're not really transformational because they haven't really reviewed the entire workflow from start to finish. So the existing approaches are still highly dependent on human analysts to review and validate the responses from large language models, which really doesn't do a lot to remove the decision-making bottleneck. So now let me talk about cached augmented generation, the technique that we use for our Kiraa application. It works by providing the large language model a rich context window filled with actual business facts, which is really what is used to eliminate the hallucinations. Users get answers in seconds, not in minutes after multiple query iterations. And they also get answers which are in natural language response, which helps them understand the answers so much better. So around 5 years ago, I developed a technique which we used in Kiraa, which would now fall under a category of approaches that you would call cached augmented generation. So this approach works by caching or generating vast amounts of training data for the AI models to consume within its context window as a single shot operation. Let me use a simple example. Today, for example, if I wanted to learn how to grow a bonsai, I might walk to the library and ask the librarian for a book on bonsai. She might say, start with this one. I read it, and then I come back with questions. She gives me another book, and I keep repeating that process until I know exactly how to grow a bonsai. Cached augmented generation, on the other hand, is a bit like going to the library and saying to the librarian, hey, I want to grow a juniper tree bonsai in a cascade style. The librarian will then select the best 5 books that address that topic and gives me all those books to read at once. My AI strategy is to consume highly curated information which addresses specific questions from an extremely narrow set of highly reputable information sources. The benefit of this approach is that once the AI has consumed the available information, it becomes very easy and quick to provide high quality answers from that training data. In terms of business analytics, this approach offers some serious advantages. The first one being speed, and that's because the information is already available in natural language. Our CAG approach does not need to do database lookups because the underlying business information is already available in natural language. We use a proprietary content generation algorithm to extract business information from source systems and convert them into enormous volumes of natural language. So when the CAG algorithm runs, it draws from the existing pool of information. It doesn't try to recreate it on the fly. This leads to both speed and quality improvements in the resulting answers. Fast, cheap and reliable business analytics has been the holy grail of AI for quite some time now, but it's been out of reach because of the technical challenges that I've mentioned earlier. This is why I'm so excited about our world-leading AI approach, which is only possible because of the analytical data frame technology that CSU has helped me patent. The analytical data frame replaces the complex information pipelines that organizations have in place to collect, process and share information. The algorithm converts raw data, such as transactions and metadata, into a predefined variable ontology, which stores knowledge in natural language. The algorithm converts raw data, such as transactions and metadata, into a predefined variable ontology, which stores knowledge as sentences, not just raw numbers. So in a traditional database, you might have a table with customer and sales like this. But using an analytical data frame, we would represent the same information as a sentence like this. On March 15, 2025, we sold 100 kilograms of widgets to ABC Proprietary Limited for $500. Take a guess which of these two methods is more suited to work with large language models. So our algorithm builds sentences, and once we have sentences, we can aggregate those sentences into paragraphs. Paragraphs become articles, and once we have articles, we form the basis of our internal knowledge base. It's these articles which we can then use in conjunction with a reasoning model to help employees make better decisions faster. We can also then make use of artificial intelligence to take this one step further and generate artifacts, such as presentations or infographics, which answer the question that the users ask in a much more approachable way. I might, for example, want to prepare a report of the sales of widgets over the last 12 months. I could then use this algorithm to retrieve all the articles, synergize that information, and output it directly into a presentation. So why is this so beneficial? Well, the cached augmented generation approach that we've taken with Kiraa is better for business analytics because it significantly lowers the cognitive burden for the employee when making a decision. We use Kiraa to draw from existing knowledge base, synthesize information, and respond to them. This allows us to completely redesign the decision-making process, replacing the human analyst with a virtual business analyst. This results in reduced search time. Employees spend much less time hunting for information because the artificial intelligence has already done the legwork. Normally, an employee might pore over multiple systems to gather the information they need. This is a time-consuming process that saps mental energy, but with CAG, all that effort is offloaded to the AI. The employee is essentially asking a question in plain language, and the system returns the summary also in plain language. And from here, you should see the immediate productivity gain. Of course, this only works if the model contains the information that the employees need. Kiraa can't answer things over which she has no training data. Therefore, building the analytical data frame is critical, and it's a complex and intensive exercise which requires significant effort from domain knowledge experts who are skilled in crafting the underlying sentence which form the basis of the knowledge base. This approach simplifies complex data into clear, natural language statements. There's no need to interpret charts or tables because the responses can be tailored to the comprehension level of the employee. Somebody in a technical role will have a much higher appetite for complex words and concepts than somebody who's performing a general role, and artificial intelligence can be used to adapt for the required audience. This is very closely aligned with the concept of bounded rationality proposed by Simon. By limiting to the extent to what's relevant, by limiting information into what's relevant, CAG fits into our cognitive bandwidth. That is, with the key facts at their fingertips, employees can make decisions much more quickly instead of having to decide which information they should discard and which information they should include. It reduces the search and processing effort required from the human, but it also simplifies the way that that output is delivered. So rather than overwhelming someone with dozens of metrics and complex dashboards, we can provide a simple, straightforward narrative or key bullet points. Humans have limited capacity to deal with complexity. If we give a decision maker a one-page summary of critical insights, they're going to be much more likely to make a decision if we give them a 50-page report where we expect them to go hunting for the answers. In fact, a recent study showed that even though data is everywhere, scarcity of time and complex information are still the main barriers which hinder operational decision-making. CAG directly addresses both of those issues, time and complexity. By delivering the gist of the data in an accessible format, humans are much more likely to make a better, faster decision. Employees can use the time that they saved hunting for information to apply their judgment, simulation, modeling, understanding what if, questioning. And the result is not only faster decisions, but much more richer insights around what those decisions mean. So this leads me now to my underlying research question, and that is, to what extent does implementing a cached augmented generation analytics system increase the revenue per employee over the first 12 months relative to the business unit's own performance baseline? I've chosen to focus on revenue per employee because it reduces all of the activity that the business undertakes down to a single leading indicator. If our technology helps salespeople close deals more quickly, this will surface in the revenue per employee indicator. And similarly, if we focus on streamlining the back-end operations, the number of people might decrease, also increasing the revenue per employee indicator. It's also important to recognize that different companies and different industries work on different revenue employee metric ranges. So it's not always possible to compare one company with another, but what you can do is look at the change in those metrics over time. My plan between now and the end of 2025 is to recruit 10 organisations who will be willing to participate in our research study commencing 2026. We've started to see various AI productivity studies being posted in the literature. the most significant of which, in my view, was a working paper published in March entitled The Cybernetic Employee, a Field Experiment on Generative AI Reshaping Teamwork and Expertise. This paper was probably the first field experiment proof that AI is more than just a tool. It acts as a productive, emotionally supportive teammate that can both substitute for and enhance employee collaboration. Organisations that realign team structures, training programs, and productivity metrics around the findings in this report can capture disproportionate value while avoiding the silo-driven technical blind spots that many organisations are stuck in today. My intention would be to publish an equivalent paper using Kira's CAG approach, with a change in revenue per employee being the key metric of success. So finally, experts agree that artificial intelligence will reshape society and the way that businesses operate. McKinsey & Company describe it as transformative as the steam engine. PwC believes it will reshape the workplace more than the internet did. And Gartner believes that 50% of business decisions will be augmented or automated by AI by 2027. That's only a few years away. But with Kira, we now have a unique, once-in-a-generation opportunity to undertake leading-edge empirical research through our research collaboration with Charles Sturt Uni. I'd sincerely welcome the opportunity to discuss these ideas further and build out a plan where this can be a win for everyone.